Okay guys, this is day 3 part 4, and if you have not seen day 3 part 3, just click here and it's gonna take you directly there. Okay, so if you're not seeing it yet, probably I haven't put it there. Alright, so if you've seen it, if you've watched the 3 part 3, let me know in the comment section by marking your register. So go there and say, yeah, I've seen it, so I will know you have. So other people who come here would also see that, okay, there's a software engineer here and they can connect with you. Alright, so let's go. This one is saying that I think back to we're having file information. So the last one we did was building a simple shell that will collect only one argument, right? Just the file, right? So now we are going to a system call called start, right? So start is a system call and it get the status of a file. You know, when we do let this thing load. Is this one load already? Okay, good. Let me seed into our shell. So when we do ls-l, we get more details of all these files, right? We get the permissions, right? We get the owners of the file, the date was created, date was last modified, sorry guys, date was last modified, and many more details. So the start system calls, right? The start system call allows us to get that as well, right? So sorry, and let's just go. So we'll mount to start and see what it does. But before that, it said on success it will return 0 and on error it returns -1. Okay, so start basically they collect two arguments. So let us man to start, sorry, man to start. Okay, yes. So if you want to use it, you have to include your system types.h and system stats.h. Okay, and then the system called header file, which is the unistd.h. Good. So where start, this is start and these are the sister functions, right? Fstart. Okay, also still to describe, they're all for giving more information about a file, right? Okay, in our Linux we have different files and then we want to give information, just like when we do ls-l, which is giving more information, right? So if you look at it, start collects just two parameter. So it collects a path name, that's the path name to the file. For example, if you have ls, okay, let's cd into, let's say we are cding into shell tutorial. So we can say shell tutorials, and then if probably I want to vi, then I can say vi into shell tutorials. I don't know if this will work, but let's try it. Test.c. Okay, so it's going to open it inside my shell, and if I say hello, sorry, hello, and I save it, right? I'm still here. So if I do ls here, I don't have it, but if I cd into my shell tutorials and I do ls, you see that I'll have my test.c. So let's see, as you can see, test.c. If I cut test.c, right, I have my hello inside, right? So let us just remove that. So as you can see, this guy is the file part, right? The file part. Okay, so we have that. So the system call will collect that, and then we'll collect what again? A struct start, right? A struct start. So this struct start, right? This struct start, do I have my notepad here? No. Okay, I'm supposed to have okay, probably this guy will have what is. So this struct start is some data that has been defined in our struct. So there's a struct that comes with this start, right, that helps us we just assign different a particular struct to it, a struct name, and then we can access those um, parameters inside the structs, right? So we can say struct to, so one struct, the struct has so many data, so each data are to fetch different things. So one can be to fetch the permission, one can be to overwrite the and to get the update the modification date of the file. So all those things are what the stat does, right? So let's see. I haven't gone through this before, so I'm going through it with you. So so it's going to be fun, and we're going to be learning together. All right. So this function returns information about a file. Okay. So um, it returns information about a file. That's just like I explained, right? That the start is just to get more information about a particular file. So in the buffer pointed to by start buff. Okay, so let us see. Is there anything like start buff here? Yes. So in this guy, right? So that's that. So inside the struct, like I was saying, look at it here. This is what I was saying. Can you see the struct is a very big struct? The start structure. All of these system calls return a start structure which contains the following. So look at the start structure. Can you see? All these are the start structures. Okay, look at it. So we have a dev underscore t and st dev, right? So this is like the variable, and then these are the variable names given to them, right? So this one will help you get the ID of the device containing the file, the inode, the file type and mode, the number of add links, the user ID, the group ID, just like we have here when we do ls-l, right? All this user and group, that will help you get it. So we have the get ID will help us get all this one, and st-gid, and then str there for device ID. The total size, we have that also here. Where is it? Is it this one? I think it is this one. Yeah, I think this is total size. That should be okay. So that this guy will help you get the total size of the file, block size for file name, number of f1 2 bytes block allocated, blah blah blah. Since Linux 2.6, the kernel supports nanosecond precision for the following timestamp field for. So we have also have some here. So this one is nanosecond precision. So the time of last access. So we can get the time it was accessed last, time the file was modified, time of last status change, and some other things. And then this one are just this one should be preprocessor, right, which are defining all these guys. So this st8 times stands for st8 time.tv sec and all those stuff, right? So basically that's it. So we can use all these things. So if we want to use them, we can just come to the man page and then access them and then see them, since the man page is not running anywhere. So we can always use them from the man page. What else? So this place part is basically telling us all the functions, like explaining more about them, I guess. So what else do we have here? What else do we have to offer? Okay, we have an example. You have an example, and then they are just trying to access each guy and then printing whatever it is. Okay, but nevertheless, we are going to still work on a task on it, definitely. And I just want to make you understand what the start is for, because that's not what we are supposed to do. We're just going to read along, follow the step, but I just want to give you that short explanation that you just pass in the file name, the path, and then a struct, right? A struct will be passed to it in order to give it those parameters, right? All right, so let's quit that. Okay, now what are we going to do next? So we know that the start will help it get more information about a file. If it is successful, it will return 0. If it is not, it will return -1, which is error, right, which is not successful. So let us see what this guy does. So we'll do our start.c and then we'll copy this guy there, right, and then we'll execute to see what it's doing. So we do our start.c, paste it. Alright, so do we have a GCC to compile that code? No. So let us just compile GCC start.c, and then the output should be start. Okay, compiled, and let's run start. Okay, so it says the usage is the command and then the path name, right? So we'll put in the command and then we'll put a path name. So what they did was they imputed two path name. It said not found, but okay, two path name, and then one says found, the second one says not found. Okay, this one they enter 3, ls, bin, and then user, right? They enter the path names, right? It means that I think they are entering like the file names, the paths to the files, right? So they enter 3 path names. So they said it found this one, did not found this one, it found this one on the Arduinos and did not found this one. So let us see the ones that it's going to find in our own system. So we have the ls, we have the bin ls, and we have this. So by the time we press enter, still the same thing, it found this one. So it means that but if I do which ls, I don't know, we used to have user bin ls, I don't know why it's not finding this one anyway, but I don't know. But at the same time, if we run bin ls, it's still gonna work. So the file path to this guy was found, this ls was found, so they are looking for ls, which is the file. Okay, so let us see what was done and how they result to this guy. Okay, so what they did is they used the file guy here, the stats rather. Okay, and as you can see, we have the type.h, we have the start.h, we have the university and standard IO. Okay, and then we enter the main, and then the main is collecting an argument, so it is an argument to main. Okay, so we have an unsigned I, probably for a loop, right, int, and then we have the struct start, right? This one comes with, is the second parameter for what's it called, for the start, right? And then they gave it st. Okay, so that's that. So we said if the argument count is less than 2, that is if we just pass just the file name, right, and we didn't pass any other parameter, then it should print that, it should print the file name, right, usage, that it should print file name, and then part of the file path to file, right? And that's what it did here, right? It prints usage and then the file name and then path to file, right? So that's what it does. So it's because our argument is just 1 here, right? So that's what that part does. And then we have this other part which says I equals to 1, right? So while AV1, that is while we have this guy, so they start from 1 this time around, AV1. So while AV1, where is it? Okay, print, okay, %s AV1. Okay, so it's going to print out that guy, right? It should print AV1. Okay, and then it said if our start, right, they pass in the argument and then they pass in the st, right, to the struct. If it returns 0, it means that it has found it, right? It should print found. So it's going to print the file name, and then it's going to print found, right, if he finds it. So basically we passed in this part, and then he said this guy not found, because we've said that okay, what else you should print not found. So it's going to first print the file name, and then it will print found or not found, and then I plus plus to increase to the next guy. Okay, so that's what we did. And then this one printed the name first, put dot, and then not found, printed the name first, and then since it find the parts, set found, and then displays the start function return -1 rather. Okay, this one is found as well. I thought it is not found. Thank you, thank God I said so. I was wondering because user being ls is found, user this is found, but this one is not a part, so it said not found. So I was thinking it is not found. Maybe I need to go and eat. Anyway, I'm not seeing it properly. Anyway, that's a good information because that was turning my head somehow. Alright, so this call keeps, please hold on a second. Thank you. So back to where we stopped, and I think that's all for now. So I don't know why it is not found here. I think I was following up this guy because on our own system, our USR being ls is found, right? So we have it on our system. So all right, so that will be all for now, and then in the next video we'll be talking about probably we'll be using the stats here to do some things, but this one says find a file in the path. Okay, write a program that looks for files in the current path, and then usage we can use which, and then define it. Anyway, we're going to see how we're going to tackle this task, okay, and then I'll get back to you. So see you in the next one, part 4, video 1. Bye.